Okay, so the linear factorization theorem, we kind of already have alluded to this, but if you have f of x equals a sub n x to the nth plus, and then you have these, well, you know you're going to have n zeros, n number of zeros, counting multiplicity. Let's put multiplicity. But you also have n number of factors, and that's also including multiplicity. So we know each zero can be written as a factor. You have n of them, and so you're going to have n factors. N zeros means n factors. Okay, now we talked a little bit about complex numbers, that they could be a zero of the function, and we had some in that one example. But we have what's called the complex conjugate theorem. And it says if you have a zero, such as a plus bi, then a minus bi also is a zero. And so it's called the complex conjugate theorem. If you have one complex number that has an I part to it, then you're going to have the conjugate of that as a zero also. Because, you know, here you have your factors, but you would have x minus a plus bi as a factor. You'd have to have x minus a minus bi as a factor, because we need our coefficients to be real numbers. And that's the only way to get rid of the I part, is to have that multiplication going on of the complex number, okay? So an example, let's say you have a zero of 2 minus 3i. Then 2 plus 3i is also a zero. So the complex numbers, the ones in a plus bi form that aren't real, they have to come in pairs, okay? So I think that's it for the complex conjugate theorem. We'll see it in the next video.